Motion. We're all familiar with motion. One of the first types of motion that you study in physics is motion in two dimensions. However, today, we're going to be talking about rotational motion, specifically uniform circular motion. When an object is in uniform circular motion, its speed is constant, since the sum of the torques acting on it is zero. However, it does have acceleration because it changes direction all the time. The centripetal force is directed towards the center of the circle, and so the acceleration that comes from it, or the centripetal acceleration, is also directed inwards. This means that velocity is perpendicular to the acceleration. When an object is in uniform circular motion, the centripetal force is the only force acting upon it. However, the centripetal force is not needed for any type of circular motion. We can actually find the centripetal force that an object has using this equation. F sub c equals mv squared over r, where Fc is the centripetal force, m is the mass of the object, v is the speed of the object, not the velocity, and r is the radius of the circle that it is traveling in. Taking this equation, we can also find the acceleration that the object has using this equation. A sub c equals v squared over r, where a sub c is the acceleration of the object, and as before, v is the speed of the object, and r is the radius of the circle that the object is traveling in. Let's try an example. Josh is riding a bike on a circular track whose radius is 3 meters. If the bike has a constant speed of 6.5 meters per second, and if the bike is 15.8 kilograms, then what is the centripetal force and the acceleration of the bicycle? Well, since we're told that the mass of the bicycle is 15.8 kilograms, the velocity of the bicycle is 6.5 meters per second, and that the radius of the circle is 3 meters, it's quite easy. We can just stick those variables into our equation. 15.8 kilograms times 6.5 meters per second squared, all over 3 meters. And you should come out with roughly 222.52 newtons. If we want to find acceleration, we can just stick those numbers into our equation for acceleration. 6.5 meters per second quantity squared over 3 meters. And you should get 2.167 meters per second squared. Centripetal force can be caused by tension, as can be found in a rope, for example. It can be caused by friction, as we saw in the last example with the bicycle, or, as we will soon see, it can be caused by gravity. However, it's always important to remember that the centripetal force is always pointed to the center of the circle. Now, I mentioned that centrifugal force can be caused by gravity. Gravity is basically the attractive force between any two objects that have mass. As of right now, there are two main theories as to why gravity exists. One theory is that small particles called gravitons create gravity. The other theory, Einstein's general theory of relativity, says that all objects that have mass warp and distort space-time, thus causing gravity. As with centrifugal force, we can find the gravitational force that any object has using this equation. Also called the law of universal gravitation, the equation is F sub g equals g times m1 times m2 over r squared. F sub g is the force due to gravity, m1 and m2 are the masses of the two different objects in question. R is the distance between the centers of those two objects, and g, also called the universal gravitational constant, is equal to 6.67 times 10 to the negative 11 Newton times meter squared over kilogram squared. Let's try an example. A coffee cup, which is 750 grams, and a book, 3,000 grams, are sitting a meter away from each other. What is the gravitational force between the two of them? Well, we're given the two masses, 750 grams and 3,000 grams. However, convert them to kilograms for the use of this equation. We're also given the distance between the centers, which is 1 meter, and we already know g. So, we can just plug those into our equation. 6.67 times 10 to the negative 11 Newton times meter squared over kilogram squared times 0.75 kilograms times 3 kilograms all over the quantity 1 meter squared. And that monstrosity comes out to 1.5 times 10 to the negative 10 newtons. So now that we know a little bit about centrifugal force and about gravity, we can tie the two of them together. In order to tie them together, however, we need to know the definitions of period and frequency. Period, or t, is the time that it takes for an object in uniform circular motion to travel through one full circle. Frequency, or f, is the number of times per second that an object in uniform circular motion travels around the circle. Frequency is measured in hertz, or 1/second. So something with 5 hertz is something that passes a certain point 5 times per second. Together, frequency equals 1/period. So let's try this final example. How fast does the moon travel in its orbit around the Earth? If the mass of the Earth is 5.7 times 10 to the 24 kilograms, the mass of the moon is 7.3 times 10 to the 22 kilograms, the radius of the moon's orbit is 3.8 times 10 to the 8 meters, and g is 6.67 times 10 to the negative 11 Newton times meter squared over kilogram squared. First, we have to realize that the centripetal force is the gravitational force, since the moon is orbiting around the Earth. Thus, we can set the equations for gravity and centripetal force equal to each other. Then we can just start filling in the numbers. Notice that m2, or mass 2, is the mass of the moon, since the moon is the object that is experiencing the centripetal force. 6.67 times 10 to the negative 11 Newton times meter squared over kilogram squared times 5.7 times 10 to the 24 kilogram times 7.3 times 10 to the 22 kilogram all over the quantity 3.8 times 10 to the 8 meters squared is equal to 7.3 times 10 to the 22 kilogram times v squared over 3.8 times 10 to the 8 meters. Notice that the mass of the moon cancels out, and so does a radius. On the right side, we're left with v squared, and on the left side, we can cancel out some units. Thus, our final answer should be roughly 1000.24 meters per second as velocity. We can also find the moon's period of orbit. Since period is the time that it takes to travel one full circle, we need to find the circumference of the moon's orbit. Circumference is 2 pi r, and we are given the radius already. And so that means that the circumference is that large number right there. We also know that distance equals speed or rate times time. Thus, we can plug in our circumference for distance and our newly found speed of 1000.24 meters per second. Thus, solving for time, we can find out that the moon's period of orbit is this large amount of seconds right here, or 27.6 days. So, in summary, an object undergoes uniform circular motion when the centripetal force is pointed directly inwards to the center of the circle of the object's movement. Tension, friction, and gravity can all be sources of centrifugal force. We can calculate the gravitational force that an object has, and combined with our equations for centrifugal force, we can find the period of an object that's in uniform circular motion, we can find its velocity at any time, or we can find its acceleration. And that, ladies and gentlemen, is uniform circular motion and gravity in a nutshell. Thanks for watching.